Welcome to Lesson 2, Example 5, and I believe we've done this one already, but we're going to go ahead and do it again because practice makes perfect. Alright, first thing you do when you have an example, actually go ahead and say what they want us to do. They want us to find the shear diagram, but we're going to go ahead and do the shear and moment again. And the first thing you do is you need to find your reactions. So we solve for reactions using the three equilibrium equations. Hopefully by now this is becoming quite fast and intuitive for you. Sum of the forces in the y direction equals 0. Sum of forces in the x direction equals 0. And the sum of the moments about any point equals 0. And knowing what we know, we say that that's not going to help us. We have 2. We have to use the sum of the forces, sum of the moments, and about any point equals 0 first, because we have 2 unknown y reactions and we can't isolate one of them. So we can isolate one of them using the sum of the moments equation. Alright, so let's go ahead. You say this is positive, and you can do whichever way is positive. I just have made it a habit to do that. Oops, let's do this sum of the moments about, let's give some points. Point A and point B. Let's move that down. Point A and point B. And remember, these, I just named them that. They can be anything. Sum of the moments about point A equals 0. And equals R1 will induce no moment because it is concurrent. It goes through point A. Alright. And then we're going to have a positive 3,000 because it's going to do us a positive moment. And that's at, oh, I didn't put the dimensions here, 4 foot, and the whole thing is 18 foot. This right here is 4 foot, and this down here is 18 foot. Let's do that. There we go. Alright, so that will be 4 foot. And then we're going to go ahead and switch colors. And we're going to say that this 4,000 pounds per linear foot will create an equivalent load right in the smack middle of that load, since it's a rectangle. And it's going to be 4,000 or 400 pounds per linear foot times 18 foot will give you 7,200 pounds. And that's at halfway. Halfway is at 9 foot. So let's go ahead and put that over here. And that's going to induce a positive moment as well. 7,200 pounds at 9 foot. Alright, now we have R2. And that's going to go ahead and induce a negative moment. So let's just put plus negative R2. Actually, I'm just going to do negative foot R2 negative 18 foot. Alright, there's our equation. We can go ahead and solve for R2. I'm going to do it in my head. So I'm going to get R2 equals what? And this is my thinking in my head. 3,000 times 4 plus 7,200 times 9. And then we're going to put the negative 18R2 on the opposite side, and we're going to divide by 18. And our answer is R2 equals 4,266.7, let's call it, pounds. Alright, now we have the sum of the moments, or sum of the forces in the y direction equals 0. And R2, remember, equals 4,266.7 pounds. Alright. Let's go from left to right. So we have a positive R1. This is going up. A negative 3,000. Then we have 7,200, which is also negative. And then we have a positive 4,266.7. Positive 4,266.7 pounds. and R1, doing the algebra, negative 3,000, negative 7,200, plus 4266.7. That means R1 should be 5,933.3 pounds. And you can check yourself real quick. Some of the stuff in the negative should equal some of the stuff in the positive. So let's look at our two reactions. 4266.7 plus 5933.3 equals 10,200. So 7,200 plus 3,000 equals 10,200. And those match up. And I'll look at the example here, and it looks like we match up with them as well. So we're good. Our reactions are good. Let's go ahead and says equals 5,933.3 pounds. All right, there we go. So we have solved for our reactions. We're ready to go with the shear and moment diagrams. We'll switch colors. So we have V as a function of X. And I'm going to try to line this up with the free body diagram. And this is the free body diagram up here. And then we go down and we go to shear diagram, and then we'll go moment diagram. Let's go ahead and do moment diagram as well. A moment as a function of X, and X is going this way. All right, so if you remember shear, we start to the left, we go up what it is. We go up 5,933.3 pounds. And remember, I typically will do this, but you could label it if you have enough room. I just find that I run out of room on this. And then I'm going to go down at a slope of negative 400. But what you do is you went up, and then you want to go down this area right here. And that area is what? It's 400 tall times 4 foot. That's 1,600. So you want to take 5,933.3 minus 1,600 equals 4,000. Let's guess it's about right here. 4,333.3. Remember, this slope should be negative 400x. That slope is going to be 5,933 minus 400x. And hopefully that makes sense. I hope it does. If not, I'll do some more videos on the theory behind moment diagrams and such later. But for right now, that will have to do. Alright, now we want to take this negative 3,000 pounds, since we got to that point, and that's going to be 1,333.3. Alright. Then we want to go down. And remember, we do not want to use this. That was the equivalent of this distributed load, but now we're using the distributed load. So let's go ahead and do the rest of that load right here. So that's going to be what? 14 foot times 400 pounds. 400 times 14 foot, 5,600. So we take 1,333.3, we minus 5,600, and we get negative 4266.7, which makes sense because we're going to go up 4266.7. Excuse me. 4266.7 pounds. And that makes sense. That's exactly where we wanted to be. Alright, we go ahead and make the line, then we go up because of this. 42.6, and we end at 0, which is exactly where we want to end. So we know we're that's our own check. If we end at 0, you're good. Typically you'll be good. I'm not going to say always. I guess it could work out where you're not, but alright. Now we look at this shear diagram and we say, hey, A cross is the the 0 line. Let's call the 0 line here, where the point of 0 shear. And we ask ourselves, what does that mean? If you remember from previous videos, you'll remember that I say that, hey, when the shear crosses, you can pretty much say when the shear goes from positive to negative, you're going to have a max moment, because all over here moment's going up, then all over here moment's going down. So when you say, okay, when moment stops going up, you're going to get the max positive moment right there. Then it's going to go down. It's going to meet back at 0. And hopefully that's starting to become, hey, yeah, I can see that. I can see that. All right, but let's go ahead and make sure that we're right. Let's go find this point. What is this point? X. Let's see, what is the 0 intercept here? And our equation is going to be this 1333. I guess you could go this way. Say negative 4266 plus 400x equals 0. And what is x? Solve for x. We'll go from here. And let's change colors real quick. And we're going to say, from this point right here, I know sometimes you can't see where I'm pointing, is 1,333.3. And then, since we're going down 400, that's what the slope is. And I've mentioned that more than a few times now. Come on, pen. Why isn't the pen working? Because I picked the wrong color. Alright, 400x. And this is pounds, but I'm not going to write those. Equals 0, because we want to find out when y equals 0. Y, or Vx, let's say Vx, that's Vx. Vx is kind of our y, equals 0. Alright, so we do the quick math. 1333.3. 400x will go to the other side, and we want to divide it by 400. And that's when x equals 3.33 feet. And you say, oh, okay, that equals 3.33 feet. 3.33 feet. Not really. That's 3.33 feet from here. So we want to go ahead and add this 4 foot. Plus 4 foot. Hopefully that makes sense, because our equation was from this point. I don't know much of which colors again. Equation was from this point right here. So we want to make that equals from the point, and we need to add the foot to make sense. 7.33 foot. All right, and that will be your place of maximum moment. And we're running low on time, so let's hurry up and go through this. It's going to be A1, A2, and then A3. And A1 equals what we have, 0.5, you have 5933 minus 4333 is 1600, and that's pounds. And this is 5 times, what, 4 foot? Yes, 4 foot. And then we add, that is the triangle above. Now we have to add the rectangle below, which is 4333.3 pounds times that 4 foot again. And that equals 20,533.2, give or take, foot pounds. And A2 equals, it's this triangle, so it's 0.5 times your distance, which is 3.33. We got that right there. Foot times 1,333.3, and that equals 2,219.9 foot-pounds. And let's go ahead and add these two together, and we get 22,753.1. Now remember, this is going to be increasing more, and then it's going to hit right here, and that's the 20,5033.2, and you go like that, and that's your point of max.